All right, if you're trying to find the most direct path into a tech career, you are in exactly the right place. Today, we're going to lay out the ultimate roadmap for landing a job using one of the most powerful skill sets out there, Python for data science. Let's dive in.
So you want to break into tech, right? I get it. It can feel huge. There are dozens of different paths to choose from. But what if I told you there's a really focused route that's not only in super high demand, but is also totally learnable if you just have a clear plan?
And let me tell you, focusing on Python combined with data science, that is a really smart move. It's one of the most valuable, most employable skill stacks you can have on the market today, and we're going to show you exactly what you need to know to get hired.
Okay, so here's our roadmap. We'll kick things off with your core data toolkit, the essentials. Then we'll get into telling stories with that data. After that, we'll build some intelligent models, and finally, we'll map out the entire process of going from a portfolio to an actual paycheck. It's a straight line from learning to earning. First up, let's build your core data toolkit. You know, every great craftsperson needs their tools, and for us in data science, that means getting really good with a few key Python libraries. This is the foundation for absolutely everything that follows.
Now look, you do not need to learn all of Python. That's a huge trap. Just focus on what actually matters for data. And that means getting comfortable with your basic data structures, lists and dictionaries, knowing how to write a function, handle some errors, and, this is a big one, how to work with the file types you'll see every single day, like CSV and JSON.
Okay, so once you have those basics down, it's time for NumPy. And NumPy is all about one thing: speed. It lets you do really complex math on huge data sets incredibly fast because it replaces those slow, clunky Python loops with these highly optimized operations. Think of it like the high-performance engine under the hood of all serious data science.
And this brings us to maybe the single most important concept you're going to learn, the data frame. The easiest way to think about it? It's just a smart, programmable spreadsheet or a database table that lives right inside your code. It's got rows, it's got columns, and it's what you're going to use to organize and mess with pretty much all of your data. The tool you'll use to work with data frames is called pandas. And let me be clear, this one is non-negotiable. This is where you stop just programming and you start doing actual data science. You'll be using it constantly to read files, clean up messy data, filter for insights, group information together, combine different data sets. This is literally what data professionals do all day long. And here it is. This is the most important point of this entire section. If you truly master pandas, get really good at it, you are already employable. Seriously. Forget machine learning for a second. This one skill is the key that unlocks the door to those junior data analyst and business intelligence jobs.
Okay, moving on. Once you can wrangle all that data, you have to be able to explain what it all means, right? See, data professionals aren't just coders, they're storytellers. They're the ones who find the hidden story inside all those numbers. And your main storytelling toolkit, your visualization stack, really has 3 layers. At the bottom, you've got Matplotlib. It's the foundation. It gives you total control to make any chart you can possibly imagine. But honestly, for your day-to-day stuff, you'll probably use Seaborn. It sits right on top of Matplotlib and makes these beautiful, professional-looking charts with just one line of code. And then, when you really want to wow your audience, you'll use Plotly to build interactive charts that they can click on and explore themselves. The goal, always, is to tell a compelling story. Now, along with great visuals, there's another skill that's, you guessed it, non-negotiable. And that's statistics. This is the language of data. Understanding concepts like the difference between mean and median, what correlation really means, and how to properly test a hypothesis, it's all absolutely fundamental. You simply cannot be a data professional and skip this part.
And I can almost hear you thinking, hold on a second. I came here to be a programmer, not a statistician. Why on earth do I need to know about p-values? And you know what? That's a totally fair question. The answer is what separates a good data professional from a truly great one.
And here's why it matters so much. All that complex, futuristic-sounding stuff we call machine learning, at its core, it's really just applied statistics. That's it. Understanding those statistical foundations is what lets you build models that actually work and, more importantly, make sense. Which is the perfect lead-in to our next section, building intelligent models. But look, we're not going to treat machine learning like some kind of mystical black box. Instead, we're going to approach it like what it is, a practical, repeatable workflow.
And the go-to library for this is scikit-learn, which basically turns this whole process into a straightforward recipe. It's almost always the same 5 steps. First, you split your data so you can train your model on one piece and test it on data it's never seen. Then, you scale your features so that one big number like salary doesn't dominate a smaller one like age. After that, you pick a model, you train it, and finally, you evaluate how well it actually did. It's a 5-step dance you'll do over and over.
All right, so you've got the technical skills. Now for the most important part, right? Turning all that knowledge into an actual paycheck. This is where we get strategic.
Your portfolio needs to absolutely scream, I can solve real business problems. So forget those generic tutorials. Build projects that a hiring manager will instantly get, like predicting which customers are going to leave or building interactive sales dashboard. These projects map directly to the kind of work companies actually pay people for. And please, please put them up on GitHub with a nice, clear explanation so people can see your amazing work.
Now, here's something interesting. After all this talk about Python and fancy machine learning, there's actually one hidden skill that is often the real deciding factor in getting that first data job.
And that skill is SQL. Let me just give it to you straight. Almost all the company's data lives inside a database, and the language of databases is SQL. For most junior data jobs, your SQL skills are far more important than your machine learning knowledge. You absolutely must be fluent in things like joining tables and aggregating data with GroupBy. It's a deal breaker.
So let's be strategic here. Yeah, data scientist sounds super impressive, but it's also incredibly competitive. The fastest path into the tech world is often through a data analyst or business intelligence analyst role. And guess what? These jobs focus on the exact skills we've been covering: SQL, pandas, and visualization. So start here, get your foot in the door, get some experience, and then make the jump to data science. It's a much smarter path. So how do you actually do all this? Here is a concrete 3-month plan to make it happen. Month 1 is all about the foundation. Get your Python basics down and go for a deep mastery of pandas. Month 2 is about communication. Learn your visualization and statistics, and practice SQL every single day. Make it a habit. And month 3 is when you build. You tackle the machine learning workflow, and you create 3 solid portfolio projects. It's intense, for sure, but it is 100% achievable.
So, there you have it. That's the roadmap. You have the entire plan from the very first line of code all the way to your first job offer. So the only question left is, what project are you going to build first?